on research progress of catalyst with metal vacancy for heterogenation. So these are the learning outcomes. Like, I'm going to revise the definition of the term catalyst and its types, and then revise the general mechanism of catalytic hydrogenation with its sport, and then we have what kind of metals that should be chosen, and then explain the catalytic action of transition metals and their compound as a heterogeneous catalyst using the idea of 3D and 4S, and what kind of spore should be used, and what are the main interactions that can occur between the metal and sport material. So first of all, what is catalyst? Catalyst is any substance that speed up the reaction, but at the end of the reaction it doesn't consume. So this is so called as a catalyst. So it has two types, like homogeneous catalyst and heterogeneous catalyst. Homogeneous catalysts are those which are in the same phase, just like in this case a solid liquid phase, a single liquid phase. But in case of heterogeneous catalysis, there are two phases, like the reactant may be in liquid phase and the catalyst may be in solid phase. So here is a graph representation, like the reactants are converted into production, but if we don't use the catalyst, there is a need of large amount of energy to activate this reaction. So here is, you can see the blue graph, it represents the activation energy required, high activation energy. But in case of red graph, you can see the reactant are converted into product with the lower need of activation energy, which are provided by the catalyst. Okay. So typical components of the heterogeneous catalysis, like heterogeneous catalysis has at least four steps. Like, first step is the option of reactant onto the surface of a catalyst, activation of adsorbed reactant, reaction of the adsorbed reactant, diffusion, desorption of the product from the surface of catalyst. Like in this case, in the first step, the incoming species bonds on the active site, and it forms a chemical bond with the catalyst. It may be use of the bonding electrons in the molecules and weakening the bond, and subsequently making the reactions easier. So in step 2 and step 3, all these steps, the absorption held on the surface of the metal, and as an orientation for occurring reactions. So in case of in step 3, it has form a collision. So here you can see there is a collision between them, and in step 4 there is a rearrangement of the electrons and the product is released. And so general mechanism of catalytic hydrogen with the sport, like the addition of a hydrogen in the presence of a metal catalyst is called as catalytic hydrogenation. Catalytic hydrogenation, the catalyst consists of a metal alloy, and it is absorbed onto the inert solid, which is so called as nickel, charcoal, etc. Here is the heterogeneous mechanism of a catalytic hydrogenation. So in step 2, in step 1, the hydrogen has a bonding. It may be broken down, and the metal catalyst form a bond with the hydrogens. Here you can see the metal surface is bonded with the hydrogen bonds. Here you can see here in step 1 they are in a fused sigma. They are in sigma bond, but here it isn't. So in step 3, here you can see in step 3 the pi bond interact with the metal catalyst and weakening the bond. So the hydrogen is transferred from the catalyst surface to the carbon. So in case of in step 4, you can see that another hydrogen is also transferred from metal surface to the carbon. So here you can see the alkene has totally reduced, and it has been the product has been can be used. So the mechanism is used for the reduction of alkenes. So choice of metals, like catalytic performance is determined mainly by the precious metal component. So the best catalyst the metal are those which perform which have these properties, like the metal which are high activity, high selectivity, and fast filtration rate and recycle capability should be higher priority. So the transition metals are the most frequently used in heterogenations. Like there are different kinds of metal catalysts, like platinum and cobalt, more rarely iridium, and different kind of that. So in this case here you can see if we use the platinum catalyst with the sport aluminum, and it reduces this alkene. But in case if you use copper, it reduces this part of alkene. So it depends upon it depends upon the selectivity of the catalyst. So it varies from metal to metal. So the transition metal are those which are in the group of in the middle section of the periodic table. Like there are transition metal commonly named as IB, 6B, 7B, and 3B. These are the mostly transition metals are used as a catalyst. So they have we know that the metals are the metals valence shell are made up of s and d orbitals, and they here in case of transition metals they have d orbital, which are usually not complete, so it can transfer or accept the electrons. So as we know that the metals are in transition metals are used as a catalyst because of their d block elements. The atoms in the metal are usually dense in the in dense phase. So they are in different arrangement to form a variety of crystal structures. So that if I say that the exposed atom on the silver metal crystal can provide high absorption and reaction rate for chemical adsorbed molecules. If we can see here in cubic body center, there are like 1 2 3 4 5 6 7 8. There are 8 electrons, 8 atoms are arranged in this crystal. So here is the central part atom. So this is a cubic structure, and it has a coordination number like 6. So if I say that the most important, so here are the so in this case there are the most important metal, the group of IB of the activities, and sometimes correlate with the lattice parameter of the metal. 3 crystal structures are important, like phase important. And nickel, copper, iridium are fall in this category, and hexagonally they are not cubic structure, and but it is a hexagonal structure, but it has a coordination number like 12. So these are the crystal structure of the metal. So choice of the metal, choice of the sport have a great responsibility, have a great role in the a metal catalyst. So here you can see the if a metal, if we use a high surface area of sport, it disperse the metal dispersion is more frequently be happens. So in general, a catalyst sport should allow for a high degree of metal dispersion. The choice of a sport is largely determined by the name of reaction system. A sport should be stable under reactions and regeneration condition, and not adversely interact with the solvent reactions product. So mostly the sports are like titanium oxide, carbon black, silica, mono, etc. So the majority of the precious metal catalysts are spotted on either on carbon or alumina. So in this graph you can see that a platinum dispersion, this graph shows us about the platinum dispersion. So in case of, if we use in case of activated carbon, it has a large surface area as compared to others. So here if you can compare it with others, you can see that the surface area is say for silica, alumina, carbon black is lower than the activated carbon. So it has a platinum dispersion is much more in activated carbon as compared to the other spores. So metal dispersion increases with the spore surface area is its effect. The effect of the increasing spore surface on a metal surface for a series of prepared on activated carbon has been shown in this figure. Thank you. So properties, what are the properties which are needed for the spotted metals? So a sport can be effectively activity, selectivity, and refining material. Critical properties of spores include surface area required for the pore size, distribution, particles, activity, basicity, and other to promote the metal spores interaction. So here you can see that different kinds of spores which are frequently used for the metal and sport interaction. The sport can have forms such as pellets, ring, extrudates, granules. Typical sports are porous solids such as alumina oxide, silica gel, magnesium oxide, titanium zeolites, activated carbons. So what are the main interaction that can occur between the metal and sport material? As we know that we have learned that the spore provides the metal dispersion, but it has a great relation with the metal particles. It has a significant effect on the metal particles smaller than, but has a small effect on large particles. Like the spore does not only ensure the high dispersion, but there is also interaction between the metal and of physically and chemically. Like and spore, there is a electronic effect, electron transfer from one atom to another atom, and there is a formation of a new bond, chemical bond. Adhesive forces are also be produces, like formation of reduced pore surface on the metal of new phase at the bond surface. So in this case here you can see that in figure 6.15, lower dispersion and highest dispersion, this has been characterization of heterogeneation and has been get from the XPS technique. So here you can see that the black dots represent us about the particles in both diagrams figures. So in first case there is much lower dispersion. If we can say that there is a this sport has much lower surface area as compared to this one. That is why there is a much more dispersion here, and the sport has much surface area as compared to that one. So here are the electron microscope for the unique opportunity of offering catalyst morphage over the spotted on silica and alumina. So here is the graph. Here is the histogram represent us about the publications from 2010-2020. So if we the red lines represent about the spotted metal nanoparticles, and the blue lines represent the spotted platinum nanoparticles. From 2010 to 2020, it is approximately studied that 37% of platinum nanoparticles has publications. So it is a very useful, and it has attention of scientific community. So because of their high surface area, selectivity, and morphologies and significant effects, so platinum is a fascinating nanomaterial, and not only in used in activation, but playing role in the hydrogenation. So this is the rising interest on the development of spotting platinum nanoparticles and metallic nanoparticles. So furfural has been considered as the most performing molecule derived from the biomass. The organic compound, you can get any of the compounds like tetrahydrofurfuryl alcohol, methyl lactone, cyclopentanone or diols are produced from this furfural. Here you can see that the furfural has been had been reduced into the different kinds of the products that whatever we want, we can create it with the we can create it. So here's the general mechanism of the furfural. So these graphs represent us about the platinum based catalyst, which with the different types of spots like platinum and carbon, platinum aluminum, silicon, etc. Here is the black lines represent the furfural conversion. So in case of platinum carbon, there is a much more conversion of furfural. So and red blue lines also represent different kinds of the products, DHFA and selectivity and different kinds of. So biometallic catalysts containing PD spotted on different materials have been recently reported. The selectivity varied within different metals and sport. For example, platinum gave rise to 23 yield of DHFA, and platinum with 23 of the yield resulting in 43 of the furan. For copper, titanium and palladium contain 98% of Fa and 90% of respectively. So it is so the major product will be Fa and platinum based catalytic via transfer hydrogenation. So here you can see the platinum crystal screening for hydrogen of with different sports. So here are the references that where I have chosen all the material, I have borrowed all the materials. So thank you.